Algebra 1 skills number 31 factor ax squared plus bx plus c. So specifically when we have a number right here, how does that change things? Okay, so we're going to use something called the split the middle term method. Not that it really matters that much what you call it. I just wanted to let you know there are multiple ways of doing this, and some are kind of gimmicky. There's two reasons why I like this method. Number one, it's fairly easy to follow and understand. But secondly, it helps for a process called factor by grouping that you'll see mostly in Algebra 2. If you're proficient at this method, then that will already help you for that. Also, some of these other gimmicky methods, it seems like almost a magic trick, and though it might be a little more efficient than this method, it's hard to explain why it works. So for our first example, we're wanting to factor this. Okay, and notice that this 4 causes trouble. Ordinarily, we would just say, what are two numbers that multiply to give you -9 but add -16? But this 4, again, keeps you from doing that. We'll explain why the 4 changes things when we look at our answer. But what we want to do is this. We're going to go ahead and group. So notice the difference here. Well, first of all, we're putting a plus in between the parentheses, and we'll see why in a minute. But we're also writing the unchanged first term here and the unchanged last term here. That creates two gaps. Okay, so we got to figure out what to do about these gaps. And what we're going to do is multiply the 4 and the -9 to get -36. And again, we're going to explain why that is when this problem is done. But again, it's not just factors of -9, it's factors of, you got to get the 4 involved. 4 times -9 is -36. So you might want to pause here. What are factors of -36 to add to -16? Well, those would be -18 and 2. -18 times 2 is -36, which again, you don't see -36 here. -18 plus 2 is the -16, so you still add that middle term. Okay, so the -36 is actually not going to make an appearance in our problem, but we need it. Okay, so you're going to put the -18 and 2 in these two gaps. And it doesn't matter which one goes where, but I like to generally put the bigger one first. When I say bigger one, that would be not considering the sign. Okay, now notice also you need the x's with them. Okay, and if you were to combine like terms and ignore the parentheses here, you'd go right back to where we started. Okay, so you do need the x's to make the x there. Let's go to the next slide here. We're going to start in the same place or start where we left off. Okay, what we're going to do next is something called the greatest common factor, which is actually a separate slideshow. The next slideshow in this sequence, we'll talk a little more about it. But in short, we need to see it here. The GCF is going to be, what is the largest number that goes into 4 and 18? Okay, so it's almost like you're on a boat, and the boat, you're trying to get somewhere as fast as possible. You're trying to unload cargo. You're trying to throw stuff off the boat to make the boat go faster, like in the movies or whatever. We're trying to get as much as we can out of here, but it has to come from both of these. So what's the biggest number that comes, out of 4 and 18? Well, that'd be 2. Okay, so what I'm going to do is divide both these by 2. I'm actually going to divide both these by x as well, because we have at least one x in every term. Okay, so I'm going to go ahead and click and show you, and we'll get into the next one. I'm taking out a 2x here because if I were to divide by 2x, that would go in there evenly and would simplify this. Okay, I can't divide by 2x squared because this only has an x. We'll get as much as we can out of there. But in this case, all we can get out is a 2x. Now over here, the 2x and the 9, there is nothing in common there. There's no number bigger than 1 that goes into 2 and 9. And I can't take an x out because there's none on the 9. Okay, and again, you just have to do several of these problems to get good at it. But 2x and 1, those are called GCF. So what we do is take those out. Okay, some people actually don't write this step. They just go straight from here to here. In our third example, we'll do that. But notice that what's in orange, I know this is a very colorful problem, a lot of colors here, but what's in orange is not only does it match, which is a good sign, but there's nothing else you can take out of here. Okay, what we did was divide. It gets into exponent rules a little bit. 4x squared divided by 2x is this 2x. 18x divided by 2x is 9. So that's where those came from. That divided by that, just coincidentally, these are the same. However, divided by goes on the outside. So you can see the same pattern here. 2x divided by 1 is 2x, -9 divided by 1 is -9, and the 1 goes out here. Well, notice these match, okay, which is a good thing, because now what I can do is think of this as one big term, and this is one big term. So I can take, it's kind of like I took up here, I can take a 2x minus 9 from both terms, and that leaves behind the navy parts, the 2x and the 1. So notice the pattern and the colors. This would be my final answer, 2x minus 9 and 2x plus 1. Now quickly, why do we need to multiply? We'll go back here and look at, why do we need to multiply the 4 and the negative 9? Well, if we look at our answer, it comes from the fact that if you were to multiply these together, what creates that middle term when you added everything together comes from these twos as well. It doesn't just come from these numbers here like it would if those were just ones. Okay, so that's why we multiplied in the first there. So we'll go through that process a second time. Okay, this time it will not be as color-coded. The same deal. So remember the first thing, we just kind of set it up by putting the 6x squared here and the negative 9 there, leaving those two gaps. We want to multiply 6 and negative 9 to get negative 54. Again, slow this down, pause it as much as you need to understand this. Then think, what are factors of negative 54 that add to 25? Okay, so those would be 27 and negative 2. So that 27x and negative 2x, again, this is not color-coded, but they go, and that 27x went in that gap, negative 2x went in that gap. So the two numbers you decide here that multiply to this and add to that is what goes in these gaps. 6x squared, negative 9 didn't change. Okay, next slide. That's where we left off. Again, think to yourself, what's the biggest thing that goes into 6 and 27? This time that would be 3. And again, you can take 1x out. Okay. So I took a 3x out here because that's the biggest thing. I'd love to take out more, but I can't. 6, for example, does not go into 27, so I can't take 6 out. Now over here, if we have a negative in this position, we generally want to take a negative out. Okay, so again, it's a 2x minus 9, coincidentally, like the previous example. I think it was 2x. There's a positive 2x there, but we want to divide by negative 1s here. Okay, we have to write something. We don't want to just leave it like it is. So divide by negative 1. The purpose of that, again, is that we know we got to get a match here. Okay, so if you divide 6x squared divided by 3x, it's 2x. 27x divided by 3x, that's 9. Again, if you divide by that negative 1, these become positive. So we have a match. So write down what those GCFs, what you divide by, write those on the outside. Then we get 2x plus 9 and 3x minus 1. Okay, that matching part you write once, and 3x minus 1 you write. We'll do this one more efficiently. Okay, so again, you might want to pause and try it. 3x squared plus 14x plus 8. Okay, so multiply 3. Here, this time we're not even going to set it, necessarily show the setup. We know we got to multiply 3 now to get 24. What are factors of 24 that add to 14? Those are 12 and 2. Okay, so notice the setup. Again, this one's a little quicker. Pause if you need to. Ask yourself what comes out. I'm not going to show you actually dividing here, but 3x comes out this time. So write 3x on the outside. If you divide 3x squared by 3x, you get just x. 12x divided by 3x is 4. What comes out of 2x plus 8? That'd be 2. Divide both these by 2, it's x plus 4. And this is good because, again, we have that match. That's what you're looking for. So we write the matching part once. It doesn't matter the order. The x plus 4 and the 3x plus 2. So factor with a number in front of it.